Thank you again for joining us today to this another session of Everyday Mathematics. Now, today we continue with the same topic of trigonometry, and we move to the semifinals of the MH 2023 Integration B. And we'll look at the first semifinal, problem number 3, which is the integral of 2 cosine x minus cosine 2021x minus 2 cosine 2023x minus cosine 2023x plus 2 over 1 minus cosine 2x, integrating from 0 to pi. We'd like to shout out to all our subscribers. Thank you so much for trusting us on this journey. And just a word of encouragement to those of you who are here for the first time or are back but have not subscribed, subscribe to our channel. This is obviously important to us because it just gives us that extra visibility. But for those of you also who are interested in getting notification, this is another way for not missing on each time we come up with a solution to some of these problems. So how I would solve this problem, I would use the identity where cosine A minus B plus cosine A plus B is the same as 2 cosine A cosine B. So focusing on the cosine 2021x term and the cosine 2023x term, we can re-express these terms as for cosine 2021, x as cosine 2022 minus x. And for cosine 2023, x, we can express as cosine 2022, x plus x. And so when we collect the blue terms together, as just highlighted here, such that we have cosine 2022, x minus x plus cosine 2022, x plus x. These can now give us it can give us 2 cosine x cosine 2022 x. And now we can factorize the first two terms in the numerator by pulling 2 cosine x out. So we're left with 1 minus cosine 2022 x in the bracket. And then for the second part, the last two terms, we can begin by pulling 2 out. And then we have 1 minus cosine 2022 x. So we have common terms here, 1 minus cosine 2022 x, and that can be factored away so that we now have 2 cosine x plus 2 times 1 minus cosine 2022 x as the numerator. Now let's go and try to simplify the denominator a little bit further. The denominator can be expressed as 1 minus cosine 2x. Cosine 2x is the same as 2 cosine squared x minus 1. So when we substitute that, the cosine 2x term with that, we get what we are showing here in green. And that results in 2 minus 2 cosine x minus, so 2 minus 2 cosine squared x, right? So we can factorize the 2 out of the denominator. And so we're left with 1 minus cosine squared x. So using the difference of 2 squares, that results into the product of 1 minus cos x times 1 plus cos x. So as we can see here, we can now cancel out the 1 plus cosine x term at the numerator and also the denominator. And so we are left with 1 minus cosine 2022x over 1 minus cosine x in the denominator. So the 2's cancel out. So using the Euler's identity, cosine x is equals to e to the power ix plus e to the power ix over 2. We can substitute that in the denominator. In the numerator, we have e to the power I 2022x plus e to the power I 2022x over 2 in place of cosine 2022x. And denominator, we have e to the power ix plus e to the power negative ix over 2 in place of cosine x. Right, so we can move further by multiplying 2 both in the to the numerator and the denominator, and then we can go further by now multiplying both to the denominator and denominator e to the power I 2022x, and also I e to the power ix to the denominator. And so essentially we have what we're showing here, right? And then we can multiply by -1 both the denominator and the numerator and denominator, so that we can rearrange what seems like a polynomial, so that we begin with the highest degree first, going down to the lowest degree. Continuing on with the problem, so we do have a what seems like a polynomial in the numerator and the denominator, where we've decided to simplify the second part into 1 over e to the power I 2021x. Now, just having e to the power I term, it's that's a little bit complicated. So we'll use a placeholder for e to the power ix, and we'll use t as that placeholder, such that the integrand is equivalent to now t to the power 4044 minus 2 times t to the power 2021 plus 1 over t squared minus 2t plus 1 times 1 over t to the power 2021. So this first part of the polynomial can be expressed as t to the power 2022 minus 1 squared over t minus 1 squared. Just as you know, it's easy to observe that transformation. Now, we're employing a geometrical progression, looking at how this first part looks like. It's evident that the summation of t to the power k from k is equals to 0 to k is equals to 2021 is the same as t to the power 2022 minus 1 over t minus 1. So essentially, our integrand is the same as the summation of t to the power k from k is equals to 0 to 2021 squared times 1 over t to the power 2021. So if we explicitly express what we are showing in this summation sign is the same as t to the power 2021 plus t to the power 2020 plus whatever t to the power 2019 all the way to 1, that's squared times 1 over 2020, 1 over t to the power 2021. So when you look at it, the multiplication of this summation, the squaring of this summation sign results into t to the power 4042 plus 2 times t to the power 4041 plus 3 times t to the power 4044. And it goes on and on and on up to 2t plus 1 over t to the power over 1 over t to the power 2021. So when you divide across by t to the power 2021, we get t to the power 2021 plus 2 to the power 2 times t to the power 2020 plus 3 times t to the power 2019 plus the 2021, the t to the power 2021 term now results into a constant because, yeah, that has been divided by a similar term, which is now the constant of 2022. And then that goes on up to t to the power negative 2021. So combining this t to the power negative 2021 and this t to the power positive 2021 into a fraction, and that we can now divide it by 2 by actually pulling another constant out. So we have an Euler expression here for each term, except the constant that has been left out. So replacing t with e to the power ix, we clearly see we have an Euler expression here. So essentially, this first term is the same as cosine 2021x. The second term is the same as cosine 2022x. The third term is the same as 3 times cosine 2019x, all the way down to the constant. Okay. So we do have our division, long division, now giving us this summation of cosine terms and the last constant there. So our integration of 2 cosine x minus cosine 2021 x minus 2 cosine 2022 x minus cosine 2023 x plus 2 over 1 minus cosine 2x is the same as the integral of twice cosine 2021x plus 2 cosine 2022x plus 3 cosine 2019x plus 4 cosine 2018x all the way to 1011. So this means that the integral is, for the first term, 1 over 2021 sine 2021x plus 2 2022 over 2 over 2020 2 over 2020 sine 2020x plus 3 over 2019 sine 2019x all the way to the constant, which becomes 1011x. Now, our limit is 0 to pi, and as you can see, any integer value, any integer multiple of pi, and a sign of that number is just 0. So both the lower and upper limits results into 0 for these sine terms, leaving us with a constant term, which is now twice 1011 pi minus 0. So the answer to our integral is 2022 pi. And that is the answer for this problem, which seemed very intricate, but using these identities, it's easy to solve it. It's been really a pleasure hanging out with you and, going through this solution with you. Just another reminder, for those of you who have not subscribed to our channel, please, we need your support on this. Please subscribe and let's grow together. Thank you very much. Until next time, it has been a real blessing being with you. Thank you.
Numbers everywhere on the